2 shows a sketch of the part of the curve with equation y equals 8 sine half x minus 3x plus 9. So I've got a trig function, but then I've also got this like linear function going on as well. X is measured in radians. Point P is a local maximum. Use calculus in the sketch to find the x coordinate of P, giving our answer to 3 significant figures. So for this, we can differentiate dy by dx is going to equal 8 cos a half x, and then I'll be multiplying by the derivative of the inside, so a half. I'm going to get 4 cos a half x. I'm using the chain rule here, but without writing it all down. And then differentiate minus 3x plus 9 just gives me a minus 3. So that's 4 cos a half x minus 3, which equals 0 for stationary points. All right, let's solve it. Cos a half x is going to equal 3 over 4. So x is going to equal, actually, let me do a half x first. A half x is going to be inverse cos of 3 over 4. And then I can use the graph to get like all the possible solutions. So that's after 2 pi. So inverse cos 3 over 4 gives 0.7227. Make sure you're working in radians. Now I'll double that, and that would actually give me this point here. So I don't want that one, so I'm not even going to worry about finding it. The next one I find would be that one there. Looking at the cos graph, it would be this one, which is 2 pi minus 0.7227. I'm interested in the one after that, the third solution. That's going to give me my value of p. So if I continue the cos curve, it's going to be here, which is actually, using the periodicity, just going to be my original value plus 2 pi. So that's the one I'm interested in. So p, x coordinate, is going to equal twice that. So I'll add 2 pi, 2 times 7.005, which is going to give 14.0, I think. 14.011. So 14.0. That's our x coordinate of p. Nice. Curve crosses the x-axis at x equals alpha, as indicated, shown in figure 2. Given that to 3 decimal places, we've got these values. So the function, explain why alpha must lie in the interval 4, 5. And the reason is that there's a sign change. So just before 4, it's positive. At 4, the function is positive. At 5, the function is negative. It's continuous. It must cross the axis in some region between 4 and 5. That's how we can know that there's a solution between 4 and 5. So we just need to write that down. So f of x is continuous. That bit is important because you can have functions that jump, such as 1 over x, which jumps between, well, from negative to positive, it jumps to being positive. There is a sign change, but it's not continuous, so there's actually no root. So f of x is continuous, and there is a sign change. The answers actually say, and the function goes from being positive to negative, but it is the same thing. So alpha must be, I would say between 4 and 5, but I'll write it as they've written it, in the interval 4 or 5. Then we're asked to apply the Newton-Raphson method. to get a second approximation for alpha. So how this works is we'd start with 5, so a little bit beyond, let's say here, and then we actually draw a tangent to the point, and then we see where it hits the axis. So maybe it hits here, and then you do the same again. You go up, draw another tangent, and if I kind of exaggerate the diagram, you can see how it's working. So let's say that. So yeah, point here, follow the tangent up. You could follow it up again, and it just ends up converging. You don't have to worry about any of that because there's a formula that just does it all for you, but that's how the formula is derived. So I want you to have an understanding of how the Newton-Raphson method is work. It's a different iterative method to fixed point iteration. Okay, so we've got f of x equals sine a half x, and it was what was it, minus 3x plus 9, I think. Let me just check that. And we've worked out f dash x, oh sorry, 8 sine a half x. And this one was 4 cos a half x minus 3. So using Newton-Raphson iteration, I can write down that x n plus 1 is xn minus 8 sine a half xn minus 3 xn plus 9 all over 4 cos a half xn minus 3. And then we were told that x0 is equal to 5, and I can just substitute that into here to get x1. Now, sometimes you have to do many answers, and I think it's just good to get into this habit. Just say 5 equals, store that as our answer button, and then it's going to be answer, that's our xn, minus 8 sine a half xn minus 3 times x, or it's going to be x0, sorry, in our case, plus 9, all over 4 cos a half xn minus 3, which gives us 4.8046. As our second approximation, which I think it was it 3 significant figures? Yes. Gives us 4.80. Nice thing about putting it in the calculator like this is that you can just keep pressing equals and it will use the new value in place of answer now. And wow, we actually get a very good approximation very quickly. So 4.80 is, in fact, the true answer to 3 significant figures. Well done.